This is integrate geometry 10.6. Again, we are still observing and exploring the segment lengths in the circle. Now, we have scenarios, we have cases. What if now you have, look, again, I said we are now exploring the segments of chords theorem. What if you have right now two chords that intersect each other inside the circle like that? There we go. Okay, the two chord, let's say this is A, B, and this is D, C. Okay, by observation, we explore, and the ancient mathematicians, they tested, it works perfectly well. Let's say if the two chord cuts at the point E, and this is what happened to the chords and their segments. Look, A, E times, look, A is times E, B equal what? Equals DE times EC. There we go. Perfect. Excellent. Don't you think? That's it. That is the theorem right here. And it's a piece of cake for you. Example, for example, if you are given right here, let's say AE is x plus 1. And let's say EB is x plus 2. Okay? Is it okay? X plus 2. There we go. If this guy right here, okay, if that guy right there is x plus 1, this guy right here is x plus 2. And if you know from here to here, there we go, use different color. If EC is x, okay, if EC is x, and then from D to E over here, if that is what? X plus 4. Then, ladies and gentlemen, they ask, what is the chords? What is the two chords? Okay, can we do this together? Let's go. Let's go. Let's apply this. And I'm working out example 1 for you too. Here we go. Okay, look. What is your AE? That is what? X plus 1. Mr. Dan, I tried to save space for you, but make sure that it is clear. Okay, X plus 1. Got it? That's AE. What's EB? EB is times x plus 2. You got it, guys? There we go. What is DE? DE is right here, x plus 4. And what is EC? EC is x. There we go. Okay, now let's do distributive all of this together. See, do you see the space? Yep. Distributive, you have what? X times x, you got what? X squared. X times 2, you got 2x. Okay, got it? 1 times x, x. 1 times 2, 2. Okay, got it? X times, or you distribute this in. Okay, x times x is x squared. 4 times x is 4x. Now look. Both sides have x squared. What shall you do right away? Gone with the wind, baby. Let it go, let it go. Okay, now, what is 2x plus 1x? That's 3x. Plus 2. This 4x right there. Did you see that? Good job. Okay, now, can I bring my x over here? 3x over here, which is minus 3x minus 3x. Boom. 4x minus 3x, you got x. So x equals what? 2. Bingo. Bingo. Boom, boom, boom. You got x is 2. 2 plus 1 is 3. 2 plus 2 is 4. So what is 3 plus 4? AB is, there we go. AB is 7. And then the other one is, wow, 2 plus 4 is 6. And over here is 2. So together, DC is, I know, insulting your intelligence, 8. Boom. Knock that out right away. Okay, that's case 1. Case 1. Now, what if in the next case you have the two lines that runs through the circle, and they share the same common external point? What would they, relate to one another? So this is the case right now we're looking at. Okay, you ready? Here we go. There, okay. Over here. That's right there. Okay, so let's call this point. Oh boy, do you see that? Okay, right here. This point right here, let me, sorry guys, I just checked the video. It's not on radar. Okay, radar. So let me point it right here for you. Okay, yeah, see it? Okay, there we go. This is fine. Look. Oh, longer ruler, Mr. Dang. Here we go. All right, here we have that and that right there. So that fits perfectly in right here. Okay, this is point E. Okay, point E, y'all. Point E. And here we have, this is the point that cut right here. This is A, okay? And this is called C, okay? Over here, this is what? B, and this is, yep, D. Okay, Mr. Zhang, if this is the case, then will the same principle work? EA times EB equals EC times ED. Whoa, look, y'all, careful. A little tricky here, but be careful. This is how the ancient mathematicians, they observed and they proved this, which is, look, if this is the case, okay, then you will have, look, EA, okay, time with not AB, but EB, register that for Mr. Dang, okay? EA times the whole line from here, that is EB. Okay, got it? Okay, write that down carefully. There we go. And this equals to what? Yep, parallel to that, which is EC times with, not CD, ED. There we go, ED. Okay, D's right here. You got it, guys? There we go. That is the theorem that you need to figure out, okay? And not figure out, but it's given to you. Now, example 2. Let's say if this is, okay, you are given right now, if this is right here, y'all look, forget the scale, I'm just using the example. If this is 4, got it? If this is 4, and right here, if this is 4, and over here is what? Over here is 5. There we go. Look, from A to B is 5. Got it? And let's say if this is from here to here, EC is 3. You got it? All right. And then from C to D is what? Is X. All right. There we go. Then can you find X for me? Yep. Can you find X for me? Careful. Got it? Let's do. What is your E right here? What is your EA? EA is 4. Got it? What is EB? EB is 4 plus 5. Because look, this is 5, this is 4. So you got what? 4 plus 5 give you? That's right, 9. Make sense? Okay, there we go. Now, this is 3. Okay, that's EC is 3. Time with ED. ED is 3 plus X. Okay, guys, be cool. 3 plus X. That's how you solve for X right there. So 4 times 9 give you 36, okay? 3 times 3 give you 9. 3 times X give you 3X. Bring that over, you got 27 equals 3X. There we go. Solve that, you will have what? That's right. Solve that, you will have X equals big 9. That's it. That is the standardized test practice you will find. Case number 2. Now we will conclude with the last case, and I will turn you loose on this guy right here. Master this, you're gonna have fun with the relationships of the angles in the circles and the segments of the circle as well. Case 3. Look at theorem 10.16 with me, would you? Okay, here we go. Am I going too slow? If you need to go fast, you can increase your velocity in your video, okay? Or you want to watch it again? Do it too. That's the purpose of video, that we make it for you. My wife and I make it for you so that you can relearn and you can have it 24/7 with you online. All right, here we go. Let's look at the last case. What if now, Mr. Dan, you have a tangent? Oh, wow. A tangent and a chord. Together, they make an angle outside, the vertex outside of the vertex is outside of the circle. Here we go. This is E, Mr. D. Wow, it rhymes. This is A. There we go. C is right here, and D is right there. Case number 3. A tangent and a line runs through the circle at 2 points. And now, what would that look like? Here we go. Here we go. ladies and gentlemen, how do the segments relate to one another? Here we go. The tangent segment EA. EA. Time with what? No one. Time with itself. Ha! EA times EA. There we go. Equals what? EC. EC. Times with? ED. Okay, guys? Yep. Register that. There we go. Okay, you got it? You got to be careful with that because this EA by itself, therefore you double that, which is EA times EA is what? EA square. There we go. Equals EC times ED. There we go. Now let's look at the example 3 and we'll finish here. Okay. Example 3, let's say that if this one EA is 16. Okay. And then EC is, we don't know what EC is. So we call it X. And we know that CD, CD used different colors. CD right here is, they gave us 8. All right. Can you figure out what is the value EC, X? All right. Go for it, guys. Go for it. Here you go. That's it. Your theorem, your definition right here. So you got what? EA. EA is 16. 16 square. So you got 16 square because EA is 16. Okay? And 16 square equals what? That equals X times with, not 8, time with, the whole thing. The whole thing is X plus 8. That's right. X plus 8. There we go. You see that, guys? So you now, what is 16 square? 256. And this is X squared plus 8X. Ladies and gentlemen, we are now back into quadratic function. Okay, now put 256 over here. So what you get? X squared plus 8X minus 256 equals 0. Mr. Dan, what on earth is this? It's okay. It's quadratic function and you cannot factor this one out. Therefore, you use what? Quadratic formula, which is what? X equals what? Negative b plus minus square root of b squared minus 4ac. You need to memorize this just like that, okay? Over 2a. There we go. Negative b plus minus b squared minus 4ac divided by 2a. What's a? What's b? What's c? A is right here, okay? A is 1. What's b? Can you see it? That's right. B is 8 and C is negative 257. Plug all the values in. You will have what? You will have two values, one positive and one negative. And you only take the positive values. In this case, you will have, it's in your textbook, which is the answer right now. You have two values, positive and negative. But in the real world, you take the length. You choose the positive values, which is your positive value right now is 12.49. Ta-da! Guys, we conclude the lesson just right there for you. Example 5 is really a real world problem with satellite, and then you can see, I mean, it's a piece of cake for you. You can knock that out, and I know you can do that. See you next video, guys.